Welcome back to the classroom. Today's topic is the study of diode and what are the application of diode. To understand the definition of a diode, it is essential to first understand the fundamentals of electrical currents. Electrical currents involve the movement of charged particles through conductors and empty space. When these charged particles, known as electrons, travel through a conductor to create an electrical current, they form an electrical circuit. There are two primary types of electrical currents in use today: direct current DC and alternating current AC. In direct current, electrons flow in a single direction, whereas in alternating current, their flow alternates rapidly. Diodes, which are a specific kind of rectifier, were initially designed to convert AC into DC, ensuring that the electrical current flows in only one direction. A diode is a semiconductor device with two terminals that ideally permits current to flow easily in one direction while blocking it in the opposite direction. You can think of a diode as a switch that regulates the direction of electron flows within an electrical circuit. Diodes have a positive terminal known as the anode and a negative terminal called the cathode. Electrical currents move from the anode to the cathode, but it cannot flow in the reverse direction. Rather than regulating traffic, a diode regulates the flow of electric current, meaning energy moves from a source such as battery. This video is sponsored by Genreviews. In a closed circuit, this energy travels through wires and returns to the source. In electrical drawings or schematics, a diode is presented by a triangle or arrow with a line segment running through one vertex of the triangle. In schematics, the diode symbol points in the direction of electrical current flow. Next is, how does a diode works? A diode consists of semiconducting materials placed between a positive lead called as anode and a negative lead is cathode. Pure semiconductors do not conduct electricity because they lack impurities, so other substances are added to modify their electrical conductivity, a process known as doping. In diodes, the two types of doped semiconductor materials are referred to as P-type and N-type. The P-type material attracts electrical charges while the N-type material releases them. When these two materials come together at the p-n junction, the difference in charge creates an electric field that allows electrons to flow in only one direction. This characteristic of diode is utilized to effectively manage the one-way flow of electrons in a circuit. Next is the types of diodes. Number 1. LED, light emitting diode. Light is produced when an electric current passes between electrodes and flows through the diode. A substantial amount of electric current is required to generate light. Number 2. Laser diode. This type of diode emits coherent light and is commonly used in devices such as CD drives, DVD players, and laser printers. Number 3. Avalanche diode. Typically operated in a reverse bias, this diode functions based on the avalanche effect. Number 4. Zener diode. Designed to provide a stable reference voltage, Zener diodes operate in a reverse bias and will fail when a specific voltage is reached. Number 5. Schottky diode. This diode has a lower forward voltage compared to other silicon p-n junction diodes, and this reduction becomes noticeable at low voltage and current levels. Number 6. Photodiode. A photodiode can detect even small currents generated by light, making it useful for light detection. Number 7. p-n junction diode. This diode allows current to flow in one direction while preventing it from flowing in the opposite direction. Next is application of diode. Number 1. The primary function of diode is to convert alternating current AC into direct current DC by eliminating certain parts of the signal, which classifies them as rectifiers. Number 2. Diodes are commonly found in electrical switches and surge protectors as they can help prevent voltage spikes. Number 3. Diodes also plays an important role in digital logic with millions of them functioning like logic gates in modern processors. Number 4. Additionally, diodes are used to isolate signals from a power supply. A key application is in removing negative signals from AC current, a process known as signal demodulation, which is essential in the radios for filtering and extracting radio signals from carrier waves. Number 5. Diodes are also utilized in the creation of power supplies and voltage doublers. Employing a full wave rectifier can provide a more stable voltage output. Number 6. When combined with a capacitor, a diode can amplify small AC voltages into much higher voltages. Number 7. Light emitting diodes or LEDs. These are used in sensors, laser devices, and various lighting applications. Number 8. Zener diodes serve as a voltage regulators. Varactors are used for electronic tuning, and varistors help suppress AC line surges. Number 9. Overall, diodes are fundamental components in operation amplifiers and transistors. Next is question and answer. Number 1. What is a diode? A diode is an electronic component with two terminals that primarily allows electricity to flow in one direction. Number 2. Do diodes help convert AC to DC? Yes, diodes assist in converting AC to DC. Number 3. What are the two operational modes of a diode? A diode operates in two modes. First one is forward biased mode and second one is reverse biased mode. Number 4. Name 3 uses of diodes. First one is LEDs are utilized in sensors and laser equipment. Second one, Zener diodes function as voltage regulators. Third one is diodes are used in digital logic applications. Fourth question is, what is a light emitting diode? A light emitting diode is a semiconductor device that produces light when an electric current passes through it. This is the brief study of diode. Thank you for watching.